Okay, here's our second review video, and it covers everything um, past the conic sections, and that starts with inverse functions. And remember that we have a simple algorithm for calculating the inverse of a function, and that is just to call f of x y and then swap the x and the y, so that now instead of this being x, it's y, and instead of this being f of x, it's the x that we swapped with um, the x in here. Now we solve for y by squaring both sides, so we have x squared is equal to 1 over y plus 2. Then we multiply y plus 2 times both sides of the equation, which is why we have x squared times y, plus 2 times x squared on the left side and just 1 on the right. Then we subtract 2x squared from both sides of the equation, and then we divide both sides of the equation by x squared, and then we we rename y as f inverse. And from here to here, what we've done is put 1 over x squared and negative 2x squared over x squared, and those x squareds canceled, so I just have negative 2. And it's very important that we consider the domain, since we are asked to determine the domain and range of each of these. We want to consider the domain of each so that our domains are defined for all the necessary values. And so to determine the domain of f, it's very easy. We just set the what's inside the radical greater than 0 and solve for that. So x plus 2 is greater than 0 because we have to have something positive inside this radical, and we also have to have something greater than 0 because we can't divide by 0. So we subtract 2 from both sides. So the domain of this function is all x values greater than negative 2. And we can take a look at that right here. Here's the graph of that function. And so there it is right there. And you can see that all x's greater than negative 2 are going to be okay to use in this function. We can't really see right here that that this graph never does actually touch negative 2 because of the resolution of the graphics program, but that is in fact the case. And now once we've found the domain of that function, that will give us the range of the inverse. And so let me take a look at that. Here is the inverse function right here. And so I'll plot that function. And you'll notice that, yes, the range is from negative 2 all the way up to infinity. You will also notice that there is there's a whole portion of the function here that is left of the y-axis, therefore making this function not one-to-one. And but you would, of course, you would exclude that part of its domain to make the function one-to-one, and so that's the domain of the inverse, which is the range of the function, which is all positive real numbers, all positive real numbers. Now the next thing we do with an inverse is to verify it by substituting either the inverse into the function or the function into the inverse. And here's our calculation of the inverse again. And so our inverse is 1 over x squared minus 2. And so I'm composing f with f inverse. That means that I take the f inverse function and plug it in to the function. So wherever I've got an x in my function, I put a set of parentheses, and inside those parentheses I substitute in the inverse function. So I've done that here. I've substituted that inverse in here. And of course 1 over x squared minus 2 plus 2 is just 1 over x squared. So that's our first step. So we have 1 over square root of 1 over x squared. And the square root of 1 is 1. And the square root of x squared is x. So this simplifies to 1 over x. And that means the reciprocal of 1 over x, which is just x. Now, if you end with just x when you make this composition, then that confirms that yes, these two functions are the inverse of one another. Had you composed f inverse with f, in other words, plug this function in to this x here, you would have gotten the same result, although I did not do that here. And then finally, we're asked to determine the domain and range of both functions. Well, the domain of f, as I've already shown, is all x greater than -2, and so that's the range of the inverse. And the domain of the inverse, which is all positive numbers, all positive real numbers, is the range of that's the range of the function we started with. And I believe the graph. Let's take another look at that graph. The graph demonstrates that, and I don't have a quick and convenient way of wiping out this. This part of the inverse function, although I could do it, but it's just like I said, it's not quick and convenient.